Today we are going to first discuss what do you mean by process, and then we will be discussing about the different types of states of the process. Now if you recall the definition of process that we have discussed earlier, process is nothing but a program in execution. So basically we are running programs. So when actually a program is in execution, we call it as a process. Then you can also say that it is an entity which represents the basic unit of work to be implemented in the system. And when a program is loaded into the memory, it becomes a process. So in a way, you can define process is nothing but a program in execution. Right? Now let us understand how actually this process is represented in the memory. So we will see one diagram and we will see the different sections associated with this. So total, when it is represented in memory, it becomes divided into 4 sections. So the diagram is actually like this. So in all, there are 4 sections. One is called as stack, one is heap, one is data, and what is text. Now let us try to understand what each of these particular sections represent. So let us first understand what actually is present in the stack. So the stack contains temporary data such as method or function parameters, return address, and the local variables. Now all these different things are essential for execution of the process. So stack is a temporary place for storing this data. Then second is a heap. Now this is nothing but a dynamically allocated memory. Maybe during the execution of a process, sometimes it may require more memory, sometimes it may require less memory. So heap provides a solution for that. So this is a dynamically allocated memory to the process during its runtime, and the process uses this heap memory according to its need. The third section is the data section. This consists of global and static variables. Now you may recall that the values of global and static variables are to be used throughout the lifetime of the program, isn't it? You may have done this in C program. So global and static variables values are available during the lifetime of that program. So how it is possible? Because its values are stored in this data section. And the last section is the text section. This consists of the current activity represented by the value of the program counter, and and the contents of the processor registers. Now you know that microprocessor has lots of general purpose register and some special registers, isn't it? So this particular section consists of contents of this processor register, and it also has one particular parameter called as program counter, which keeps track of the current activity that is going on in the process. So this diagram represents that when a program is loaded into the memory, right, so it becomes a process, and there it can be divided into 4 sections. What are these 4 sections? 4 sections are stack, heap, data, and text. State means what? Means say suppose at one particular moment what that particular process, you all are listening to me. So that is a listening state. Similarly, a process may undergo different states during its execution, right? So let us now understand what are the different states of the process and when each of them occurs. As I have defined, at a specific instant of the time. And this particular diagram represents the different states of a process. Okay. So here, as you can see, 5 states are there: new, ready, running, terminated, and waiting. So one by one we will understand what actually happens within each of these states. Now once the particular process enters the system, okay, it is first created, isn't it? So this is the new state, isn't it? In the new state, what is happening is that the process is being created. Now at this particular moment, it does not have any memory, nor it has the attention of the processor. It is just being created. Now from new state, when it will go to ready state, when it will get the memory. So when if you recall, in the while discussing the task schedulers, we have discussed one long-term scheduler, right? So what this long-term scheduler does is that it picks up the process from this and it allocates memory to it. So what happens in the ready state is that it has been allocated the memory for its execution, right? But yet now it has not got the attention of this particular processor. So it is waiting for the attention of the processor in the ready state. So from ready state, it goes to then the third state, that is the running state. Now as here the name is suggesting scheduler dispatch. So what is happening here is that the CPU scheduler, okay, it picks up the job from this particular ready state and it allocates the processor to it. So from ready state, the process is picked up by the processor for its execution, and in the running state, all the instructions of the process are being executed by the particular processor. Now from a running state, now it may encounter three states, okay. If everything is okay, then the process completes successfully and it is terminated at the end. Then second condition may be that, say suppose a current process is going on and suppose a process of higher priority enters the system. Then what is going to happen? Interrupt will take place. And from running state, it will again go back to the ready state. When the interrupt will occur, when suppose this process is currently executed, right? So suppose some another process enters the system and it has a higher priority than this current executing process, then the current process will be, means for a while it will be interrupted, and this process will then go back to the ready state. Now here again in the ready state, what is going to happen? It will again wait for the attention of the CPU. When it goes back to ready state, then after some time this scheduler dispatch will then again send it to the running state. So this is the second condition that will occur. Then the third condition that may occur is the waiting state. Now suppose a process is currently going on. So maybe for some of its execution, it may require some data from IO device, or it is waiting for some signal, right? So in that case, it will enter the waiting state. So a process will enter the waiting state if it needs to wait for a resource. Maybe say suppose it is waiting an input from keyboard, or suppose it is waiting for some file present on some IO device, and till it is completed, it will go on waiting, and after that particular IO or event completion, then it will become ready. Ready means what? It is ready means memory is allocated, but it is waiting for the attention of the CPU. So these are the 5 states of this particular process.